Hello, everyone. Welcome back. Today, I'm going to be talking about multiplying and dividing polynomials. So, I want to go through some of these examples here. So, what do we do to multiply polynomials together? Well, what we do is we multiply the coefficients together when we're multiplying our polynomials. And then when it comes to our variables, well, what happens when we multiply you know, certain variables of the same base together with different powers or the same power, we add the powers together, right? Recall back from when we did our exponent laws that we said that x to the power of m times x to the power of n is equal to x to the power of m plus n, right? Remember we did that? And so given that we did that, we'll move forward and continue with that for today. All right. So let's do the first one. First off, what is 2 times 3? 2 times 3 is 6, so we multiply the coefficients together. What is x squared times x? Well, remember that x is the same thing as x to the power of 1, and when we multiply these two uh, these two variables together, we add up the exponents because it's the same base. So base is still x, and it would be x to the power of 3. Very good. Okay, let's try the second one. Negative 9 times 8. Well, that's going to be negative 72. So first thing I did is I took the coefficients and I multiplied them together. Now we have the powers, right? So we have the exponents. So we have x to the power of 7 times x to the power of 5. So we're multiplying two exponents together with the same base. So we add up the exponents. So 7 plus 5 is 12. So x to the power of 12, like that. Good. Okay, so it's quite repetitive. We do the same thing kind of for the rest of these, but I will still go through it. This next one is, let's see, 4x cubed times 2x to the power of 7. So let's start with the coefficients. What is negative 4 times 2? Well, that would be negative 8. And what is x cubed times x to the power of 7? Well, if we add up the exponents, we get 10. So the answer is x to the power of 10. There we go. Okay, the next one, 10 to the power of 5 times 8x to the power of 8. All right, so what's 10 times 8? Well, that would be 80. And then we have x to the 5 times x to the 8. That would be x to the power of 13. Very good. Okay. Then let's do 5. 5 says 9x squared times 3x cubed. Well, that would be 27x to the power of 5, right? We multiply 9 times 3. We multiply x squared and x cubed and get x to the power of 5 that way. All right. Number 6. Let's see. Negative 4 times 6 is negative 24. And then x squared times x to the power of 9 is x to the power of 11 overall. So that's good. Okay, number 7. We have negative 4 times 3. Well, that's negative 12. And then we have x squared times x to the power of 10. So that's going to be x to the power of 12, right? Because we add up those exponents, we add up the 2 and that 10. Good. Okay. Number 8. Let's see. 15 times 3 is 45. Then we have x to the power of 13 because we're adding up 4 and 9. So there we go. Okay. Now, 9 to 14 are a little bit different. In this case, we have two different variables for each. So there's kind of a third step here. So we have to multiply 7 and 9 and get 63, first of all. And then we have to multiply x squared and x cubed, and we get x to the power of 5. Then we multiply y to the power of 5 with y, and that's going to give us y to the power of 6. So So there we go. So this one, very much the same steps. It's just we also have to account for the fact that there is now um, another variable in the mix here. Okay, and number 10. Let's see, 8 times 3 is 24, and we have a negative 8, so it'd be negative 24. Let's see, x squared times x cubed, well, that's just x to the 5. And then y to the power of 4 times y to the power of 10. Overall, that's y to the power of 14. There we go. Awesome. All right. The next one is number 11. Let's see, negative 9 times negative 10. Well, that's 90. X squared x cubed would be x to the power of 5. And y to the power of 9, y to the power of 10 is y to the power of 19. Okay. In this next one, we have 9, and we don't have any other coefficient other than 1 for our other term, so we're just going to say this is 9. X squared x cubed is x to the power of 5, and then y9 would be y to the power of 10. And then 13, let's see. 5 times 7 is 35. Then we have x squared x to the 7, which is x to the 9. Then we have y to the power of 9 times y to the power of 5, which is y to the power of 14. Okay, then we have negative 14 times 3, which is negative 42. Then we have x to the power of 12. And we don't have anything else for y. It's just y cubed. I don't see anything else with y in it, so we just copy that in. And there we go. The next one says, find the area for the following. So just a reminder, area of a rectangle is base times height. So to find the area, what we must do is multiply these numbers together. So 12x to the power of 6 times 3x squared will give us the area. So 12 times 3 is 36. And x to the power of 6 times x squared is x to the power of 8. Then for 16, 2 times 4 is 8. X times x cubed is x to the power of 4. And y squared times y is y cubed. And then here we have all the sides are the same, and one side is 5x to the power of 7. So we're going to do 5x to the power of 7 times 5x to the power of 7, which is 25x to the power of 14. And there we go. Okay. All right, now let's move on to dividing polynomials. So when it comes to dividing polynomials, what do? We first divide the coefficients, right, as we did with multiplying. And then instead of adding the exponents, we subtract. It's always the top exponent minus the bottom exponent, right? Because if we think about it, if we have 3x's here and 10 here, then shouldn't the x's on the bottom cancel out 3 of them from the top, leaving us with just 7? Well, yes, and that's why this works, right? So let's do it. 30 divided by 5 is 6. And then if we subtract those exponents and do 10 minus 3, we get 7. So we'll get 6x to the power of 7 for this one. For 12, it's going to be 32 over 2, which is 16, x squared. So there we go. Okay. Then for 13, it's going to be 55 over 11, which is 5. And then x to the power of 6, x squared over x squared is x to the power of 4. Then for 14, we have 16 over 8, which is 2. And then y to the power of 5 over y to the power of 3, which is going to be y squared, right? Because we subtract those exponents. All right, for 15, we're going to get 80 divided by 4, which that's 20. And then we have, we are going to do 5 minus 2 for the x, for the new x exponent. And then for the new y exponent, it'd be 7 minus 3, which gives us 4. So there we go. For 16, negative 25 divided by 5 is negative 5. And then let's see, 7 minus 2 is 5, so we have x to the power 5. And then 9 minus 7 is 2, so we have y squared. Okay, what about number 17? We have negative 70 over 10, which is negative 7. And then we have x to the power of 8 over x cubed, so that's x to the power of 5 when we subtract those. And then when we do 10 minus 7, we get 3, so the new y exponent would be cubed. There we go. Okay, then for 18, we have 60 divided by 4, which is 15. And then our new x coordinate, or our new x exponent, would be 9 minus 6, which is 3. And our new y exponent would be 5 minus 4, which is y to the 1, which is just y. So we can just write y there. Okay. Then number 19. Let's see, 10 over 4. Well, that doesn't actually reduce into a whole number. But what that does reduce to is 5 over 2. So I can put that there. I can do 5 over 2. And then if we have x to the power of 8 in our numerator and x squared in the denominator, and we subdo 8 minus 2, we get 6. That's x to the power of 6. And then we have y to the power of 5 for both. Oop. So these just cancel each other out. All right. And then we have 20. So 6 divided by 12, well, that reduces into 1/2, right? And then we have x to the power of 5 over x to the power of 4, which is just going to give us x. Then we have y to the power of 5 over y, right? And y is the same as y to the power of 1, right? And so 5 minus 1 gives us 4. So it would be y to the power of 4. Then this next one, we have 20 over 30, which is the same as 2 over 3. Then these x's, x cubed and x cubed, they cancel. And then the y to the 8 and the y to the 7, we do 8 minus 7, and we get y to the power of 1, which is just y. So we'll include a y there. Okay, this next one is 144 over 12, which actually does have a whole number answer, and it's 12 itself. And then we have x to the power of 5 over x to the power of 4, which just gives us x to the power of 1, or x. And then we have y to the power of 18 over y squared, which if we do 18 minus 2, we get 16. So we'll do y to the power of 16. There we go. 23 says that a student did some work here, and we need to correct the error. There is an error in the student's work shown below. The question was to simplify 80x to the power of 9 over 16x to the power of 4. And let's see, what did the student do? Let's see, the student first wrote down the question, which that's good. Step 1 looks good to me. Then the student, what did they do here? I guess I gave away the next steps where they messed up because I'm not sure what they've done here. But basically, they said that 80 over 16 was 64, which that's not right. How did they get that 80 over 16 was 64? I'm not sure. But let's say that the problem was, the error is that 80 over 16 is actually equal to 40 over 8, which is equal to 20 over 4, which is equal to 5. So this is equal to 5 overall, right? not 64. So they made a calculation error in from this step going to this step. This should actually be 5, not 64. So that's the issue they made. Now, in their last step where they said x to the power of 9 over x to the power of 4 was x to the power of 5, that is good. That was okay. So therefore the actual answer is going to be 5x to the power of 5, right? Because instead of 64, which I'm not even sure how they got that, unfortunately, the actual answer would be 5, 5. 80 over 16 would be 5. Good. Oh, okay. Now I understand. It says the student subtracted the coefficients. Okay. Yeah, they said 80 minus 16 is 64. Okay. That makes sense. I thought it was kind of randomly that they came up with 64. But no, that makes sense because we subtract the exponents, right? It's what we do is we subtract the exponents. We don't subtract the coefficients, right? It doesn't work like that. Okay. Very good. Well, that is it. That is it for today's lesson. Good work, everybody. I will see everybody next time to talk about the rainbow rule, aka the distributive property. So we will see you for that. Bye, everyone.